Great. Thanks very much for the introduction. And it's great to be here. I hope you've enjoyed the past few days where we've seen so many discussions about the roadmap to quantum value. And what I've seen is that this roadmap looks very different for different applications, different qubit architectures. But I think what we can agree is the transformative potential of quantum technologies. But I think it's also fair to say that the path to this transformation is not necessarily straightforward. And what I want to talk to you today about is that it's probably a path that we best take together. A path where we have a shared vision of what quantum value is and how to get there. And paying homage to the cartoon and the revolution of this conference, my cartoon over there is showing that to deliver real quantum value, we need an inclusive ecosystem. And I think at the moment we're at the center, we're at the hub where we've got the people at this meeting, people working on the core quantum technologies. But to really unlock the potential, we need to look much broader. And so it's my view that an inclusive ecosystem is really a growth engine, particularly whether you're in government, business, research. And to me, the path to quantum value is not a solitary sprint, but it's a collective journey. And the most powerful accelerator is each other. But it's at this point I challenge you to think about who is part of this ecosystem and what technologies are part of this ecosystem. Is it just the people who are at this meeting? Is it theoretical physicists, engineers, software designers? We've even seen it extending to talking about energy areas, finance, pharmaceuticals. Or should we be looking at more diverse talent pools? Should we be not just thinking of materials scientists, but production engineers, design engineers? Should we be thinking of the creative industries that really draw quantum technologies into the consumer everyday experience? And when we think of the technologies, are we just thinking of the very narrowband lasers, the cryogenics, superconducting qubits? Or should we think of the often overlooked technologies, which may be the actual enabling point? It may be that point that unlocks bottlenecks and is the real value in the supply chain. And I think it's really great to have this government and policy track, because these questions are really important. What skills do we need in the future? What should we be teaching at schools? What should we be looking at universities? Or are we looking at technical skills that we need to develop? And which sectors should we back? Is it just, the high-tech sectors? Or are there some sectors that we are thinking they're not quantum, but in fact, they may well be the real critical step? And if you're anything like me or the public or funders and ministers, we want this quantum value yesterday. I think we first need to start to think about what quantum value means. And I think that could be different for different scenarios and different industries. But I think as the road to quantum value is unfolding, this inclusive ecosystem isn't just desirable, it's arguably the most powerful accelerator, and we should be mindful and open to what that involves. So I'm going to go on to give some examples from other technologies to see if there are some lessons that we might be able to learn to accelerate progress to quantum value. So this is a cautionary tale, and it comes from the sector of nanotechnology. So this economies of promise was coined by an academic at the University of Sheffield in the UK. And he was talking about new technologies and emerging technologies going through this cycle of this new era. There's all this hype, And we reach this thought of we're going to have miracle cures to diseases, we're going to have solutions to all our environmental and societal problems. And this so-called cycle of hype is fueled by excitement and expectation, but it's followed by what he called the could trap. And this is where we often find ourselves saying this work could lead to a breakthrough. And if you live in the world where I spend most of my time in the research world, we're demanded by funding agencies, and arguably rightly so, to say, where is our work addressing national priorities? How is it answering sustainable development goals? And we find ourselves writing grants to say this breakthrough, which we know is no doubt incremental, could lead to something far greater. And that by no means is untrue. It's just we're measured and we know that there's uncertainty in that, and we know that the timeline could be very long. And the same is true when we're talking to policymakers and giving scientific evidence and saying, this new technology we think you should back could lead to this societal benefit, or VCs requiring some return on their investment. But we know ourselves that the timelines for delivering this go far beyond funding cycles, far beyond political election cycles. And that's okay for us, because we know this. But this could trap is when this is extrapolated into actual certainty by members of the public or other funders, and it starts to break potentially the trust and the good work that needs to be done in the long term. And another thing I think is more so difficult with quantum technology as compared to the nanotechnology example. We perhaps have often heard things of saying nanotechnology is a billionth of the size of a human hair, or something tangible that people can relate to. The quantum world is so different to our everyday world that I think particularly so in the quantum world, there become myths that a quantum computer will instantly solve all the world's computations overnight. Or on the other side, all of a sudden, all our passwords are going to be cracked. And of course, we don't know the direct pathway that this is going to take, but I think this hype cycle for quantum technology can lead to myths that can really make us vulnerable to higher expectations. And so the cost of these unfulfilled promises, although we didn't really promise it, is it erodes progress and it breaks trust. And I think if we think about how most people interact or get scientific information, it's through the mass media. It's not through scientific papers where these uncertainties and cautionary aspects and expectations are moderated. So I think it's incumbent on us as working in the quantum sector to be good advocates, to advise, and I think we've heard over these last 2 days that although we know the promise of quantum, we also realise that real transformation is down the line. And I think another antidote for this are the case studies, and there's been some fantastic examples of that across the different sectors of pharmaceutical, finance, energy, defence. And I think as the technologies grow, what those use cases look like will evolve as well. So I want to now move to what lessons we can learn from information technology. So I think there are some analogies here, particularly with the quantum computing, in that once upon a time we had mainframes that were confined to massive rooms. And then as technology developed, the hardware got smaller, the processors got faster, and we moved. But this, as I said, this jump from a mainframe to the computer in our pocket, that is our smartphone, wasn't a single leap. It was lots of jumps. And if any of you are as old as me, I remember as a child, our neighbours were had more money than us and had this fancy Commodore 64 computer. And I remember sat as a child waiting for the tape to rewind so we could marvel at controlling a large rectangular symbol on the screen with our joysticks, playing Pong across the screen, thinking how amazing that was. And I think the things that we can see, though, the message is that whilst making hardware faster and smaller is really important, is actually how we can get a profound shift on how we build and use and interact with this. And I think we're probably in the specialist era, I think, if we think about the quantum technology. We're in the specialist era where if someone said they work on IT, in that era, they were someone who had maybe a PhD in software engineering or mathematics, and were working on machine code, various specialist code that had, certain capabilities. But I think a real breakthrough happened when we had higher level programming languages, when people like me could then use software development kits or APIs and program things. And then even massive breakthrough came in the app economy, when there now are millions and millions of software developers making apps that are now encompassing everyone from the creative arts to still the software engineers. And so my point here is that the true explosion of value in IT, it didn't happen when the technology became more complex. It happened when it became more accessible, more diverse, and when the ecosystem embraced the full spectrum of skills. And I think that's a lovely place I hope quantum will get to. And how did we get there? The real power of that was abstraction. So unlocking value beyond the raw power. So at the base of the layer, we've got the core technologies. And that's where I guess a lot of quantum is. And again, the real accelerator that we can perhaps learn from IT is that it wasn't faster or smaller hardware, it was abstraction. It was broadening participation. And we didn't dilute the technology, but we exponentially magnified its impact. And I think, a lovely thing I think of now is that people will say, I work in IT. And that might still mean they work on machine code. But it also might be that very valuable person when I'm locked out of my computer because I've lost my password or crushed the system and I've got a grant to put in, who can recover my password. And I think as we have these layers of abstraction, the quantum value changes and the timeline on which we see value is different. So I can see huge value in someone who works in IT helping me with my password that I probably wouldn't have thought of 30 years ago or so when people were working on machine code. So I think we have a lot to learn and a lot to gain. And now I want to keep talking about the smartphone, but now I want to talk about what technologies are and aren't in the ecosystem and where value is. It's no surprise that the integrated chip is an essential part of our phones. We've got the processing capability of it. And the semiconductor industry continues to play an important role. It plays a very important role, certainly in the supply chain, as we've seen with different geopolitical situations. The supply and ability to fabricate these chips really does impact the world. And another area that's probably not surprising is battery technology. So batteries at least untethered us from the wall. We might have started off walking around with big bricks, but then they became smaller due to battery technology. And then that was fine, because phones were telephones and you maybe sent messages. And then the phones became not just your phone, it was your camera, your torch, your everything. And instead of charging them maybe once every week, we're now charging them much more frequently. And that's transformed by battery technology. And we've also seen the evolution from 2G to 5G. So now, instead of just hoping to send some text-based message, we can stream videos. and we're on the cusp of 6G. But again, no surprise really. But what I want to highlight in this story of the smartphone is that whilst the semiconductor industry, power electronics, and the telecoms industry were charging along with their advances, the smartphone hit a real bottleneck. The bottleneck was having a glass that wasn't fragile, that wasn't so thick, and it was okay for the user experience. And it turned out that a glass-making company, Corning, held a huge slice of the value in the value chain for the smartphone. And arguably, if you were to look at the number of cracks on my display, I think there's still some work to do. But this is just a tale to show that we started off with a semiconductor industry, and then we found in the value chain, actually a glass-making company held a lot of it. So my question is, what's quantum's gorilla glass? What's the quantum thing? And I think it's something that certainly for policymakers and governments, we need to start to forecast. I've got a few examples there that might be these non-obvious cross-cutting technologies. So we heard in the plenary special session today how quantum machine learning can help find defects in additive manufactured parts. But additive manufacturing is helping quantum sensing become a reality. A real jewel in the crown at my university is the work of my colleagues who have got a spin-up company where they use OPM magnetometers to sense the magnetic fields in the brain. And if you look at the IP that they hold, it's all around the 3D printing of the helmet that holds the OPMs in place. We're also seeing 3D printed being used to make actual components. So the vapor cells are now also being 3D printed. We also talk about quantum for communications. Quantum's going to make secure communications. But have we ever thought what 6G could do for quantum tech? So we talk about future distributed computing. That's going to need an awful lot of control signals that are fast, low latency, and across a wide network. So perhaps this is one of our, potential cross-cutting capabilities. For billions of years, biology has been making things, and we're moving from synthetic biology to engineering biology, where we're seeing real benefit in the engineering aspects. So could we use bio-inspired self-assembled scaffolds or templates for qubit interconnects, or DNA as nature's ultimate memory storage? So I guess it's not whether any of these are, and I don't suggest that I have the answer, but it's more about asking the question, what are the real enabling technologies that could be that gorilla glass for quantum? And I guess what I'd then like to say is that these things won't just happen unless it's nice to say we want an inclusive environment and ecosystem. But we need to build it, we need to plan, and we need to communicate. We need to stop having quantum just being for physicists or the few. My tenet is quantum should be for everyone, but to do that, we need to make sure we have the right education, upskilling. We need this cross-disciplinary collaboration. And policy and advocacy, I think, is really essential. It's a difficult topic to convey succinctly, and it can get misunderstood. So I think, it's really important that we bring everyone to the table, that everyone has a voice in this journey. So with that, I will finish. I will thank those from the British Embassy for facilitating this opportunity to speak here. I'm funded by the Royal Academy of Engineering, so I'm a physicist by training, but an engineer at heart. And thank you for your attention and participation.
Thank you, Melissa.
Okay.
Any questions for Melissa? before we break.
Yeah.
Thank you. It was really nice. It's maybe also a comment, and maybe you can comment on it, because you mentioned artists and creative art, and it reminded me of the people that joined a space industry, and they were really good in origami. And they were the ones that actually contributed to inventing how the solar panels should. So I think there is way more that people from other could do than only bringing it to customers. There is plenty of work in design of these new materials, and I'm curious if maybe you had more example, if you acquire, you came across more examples like that.
Yeah, that's a really lovely example. I'm not actually sure I can top that. I think innovation and creativity go hand in hand, and I think science and engineering often think a certain way, and I think having I'd really love the people in the creative arts to be involved. Like, I mean, one aspect, I have the idea of quantum gaming, like more immersive and realities. But I think what you've said is really interesting too. It's actually that creative mindset of problem solving in a way that we didn't think so. So I think these could unlock things where we're systematically following a certain way, and you've got someone coming out and go, well, what if? Have you tried it this way? So yeah, I love that.